Earth's magnetism. The study of magnetic field of Earth is called Earth's magnetism. What is the evidence of magnetic field of Earth? You know, Earth behaves as a huge magnet. What is the evidence for it? The evidence is very simple. When we suspend a bar magnet, it always rests, it always stays in one direction, not south direction, right? Because of the magnetic field of Earth, the north pole of suspended bar magnet is attracted by the magnetic south and vice versa. So that is why Earth has its own magnetic field and Earth behaves as a magnet. What is the strength of magnetic field of Earth? You know, SI unit of magnetic field is Tesla. The strength of magnetic field of Earth is about 1 Gauss. Gauss is CGS unit of magnetic field. 1 Gauss is 10 raised to power minus 4 Tesla. This is the relation between Gauss and Tesla. Now we shall discuss why does Earth behaves as a magnet. What is the cause of Earth's magnetic field? See, cause of Earth, there are two possible causes. First, if you see the internal structure of Earth, deep inside the Earth there is a hot molten iron which is circulating between core and crust. So this has got charged due to friction. You know, it is circulating, so it has got charged due to friction. And we know whenever there is a moving charge, it produces magnetic field. So moving charge iron produces magnetic field of Earth. So what is the first possible cause? Charged circulating iron. Charged iron circulating between core and crust of Earth. And that is inside the mantle. Mantle is the layer of Earth between core and crust. Now, crust is very thick, thin. This is core, solid almost. Crust, between core and crust, this is mantle. So there is hot molten iron which is circulating. This is charged circulating iron. So the currents which are produced due to charged circulating iron are called convection currents, and they causes the magnetic field of Earth. Second possible reason of magnetic field of Earth is due to rotation of Earth. Due to rotation of Earth, the charged ionosphere, uppermost layer of atmosphere is called ionosphere. It has got charged because solar radiation directly hit the ionosphere. So ionization takes place and there are a large number of ions and free electrons in ionosphere. And due to rotation of Earth, it gives rise currents. Currents are produced due to rotation of Earth. These currents give rise to Earth's magnetism. Now, see the general features of magnetic field of Earth. You know, Earth has its axis of rotation. These poles, geographical north pole and geographical south pole. A freely suspended magnet comes to rest almost in the direction of geographical axis, but the direction of freely suspended magnet is shown here. The north pole of suspended magnet is towards the geographical north. South pole of suspended magnet is towards the geographical south, right? So what is the evidence of this? What is the conclusion? The north pole of suspended magnet must be attracted by the magnetic south. So this must be magnetic south, and the south pole of suspended magnet must be attracted by the north pole of magnetic field of Earth. This is magnetic north, and M for magnetic, north pole, right? Now Earth is rotating about its axis, geographical axis, which is also tilted, and magnetic axis and geographical axis makes an angle around 11.3 degree, right? This is geographical equator, and then according to the magnetic axis we have magnetic equator. This is magnetic equator. The magnetic lines of forces of bar magnet are directed from north to south. See, magnetic lines of forces of bar magnet from north pole to south pole. Alright, they form closed loop. And the magnetic field lines of Earth, they are directed from north pole of Earth towards the south pole. Magnetic field lines of Earth's magnetic field, north to south. Now you see at a point somewhere here, the magnetic field lines, you see on the left hand side here, magnetic lines of Earth and magnetic lines of bar magnet, they are opposite. So there must be some point where magnetic field of bar magnet and magnetic field of Earth cancel out. So that point at which the magnetic field of Earth and magnetic field of bar magnet cancel out is called neutral point. So now you see geographical poles and magnetic poles do not coincide, right? Earth has its axis of rotation. The poles which are passing through the axis of rotation are geographical poles, and suspended magnet comes to rest in the direction of magnetic poles. Suspended magnet, north pole of suspended magnet comes to rest in the direction of magnetic south, and south pole of suspended magnet comes to rest in the direction of magnetic north, right? So we have these features of magnetic field of Earth: magnetic equator, magnetic axis. If you go to the magnetic poles, right, suspended magnet or magnetic dip needle becomes vertical, dip needle becomes 90 degree. At the equator, magnetic equator, angle of dip becomes 0, right? BH, horizontal component of Earth's magnetic field. At the magnetic equator, BH is equal to resultant magnetic field, but at the magnetic poles, BH is equal to 0.